Hello and welcome to another episode of Maths with Mrs. Banks, where we make this fun and easy to learn. And in this video, we're going to focus on factorization for mathematics grade 9. And this is part 2 of a 4-part video series. And in this part, we're going to focus on the difference of two squares and how to factorize that. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on part 3 and 4 and more videos we upload in the future. We have a lot to cover, so let's start. In summary, we're going to look at number 1, the squares times table, why it's important to know how to work it out and identify it. Number 2, we're going to look at the basic difference of two squares, how to factorize using the difference of two squares, the simple ones. Number 3, we're going to look at the complicated difference of two squares and how to spot it and then take out what it is that you need to take out so it can be clear you are dealing with a difference of two squares, because not all of them are that easy to spot. Let's start. Now, starting with the squares times table, by now you should know in the times table that when you square 1, for example, 1 times 1, that will give you 1. And when you square 6, 6 times 6, that is 36. Similarly, when you find the square roots of these numbers, for example, the square root of 9 is equals to 3 because 3 times 3 equals to 9. So the square root of a number tells you the number that you need to multiply by itself in order to get the number inside of the square root. The square root of 100 is 10 because 10 times 10 is equals to 100. Now you understand the difference and the relationship, the link between squares and square roots. If you can take a square, if you can get a square, you can take a square root. If you can get a cube, you can get a cube root. Now the same applies for your variables. Now if you multiply y by y, that gives you y to the power of 2 or y squared. Using the rules of exponents, if you multiply y to the power of 5 times y to the power of 5, that will give you y to the power of 10. Now notice that y to the power of 10 is simply 2 times y to the power of 5. Not 2 times, but it is y to the power of 5 or raised to the power of 2. It's the same thing. Let me show you exactly what I'm talking about. Y to the power of 5 or raised to the power of 2 becomes y to the power of 5 times 2, which is equals to y to the power of 10. Now what happens is that with the square root of y to the power of 12 is equals to y to the power of 6, because y to the power of 6 times y to the power of 6 equals to y to the power of 12. It works the same way as with the numbers. Now I want you to notice something here. The square root of a number in general, a to the power of, okay, let's use y to the power of 8. That means y to the power of 8 all to the power of 1 over 2. That's what this square root, which it basically is 2, but we don't write that because the assumption is that that is 2. And that gives us what? 8 to the power of, y to the power of, 8 over 2. And 8 over 2 is equals to 4. And that's how you work that one out. In general, you should know, according to the rules of exponents, that a to the power of m, the nth root of a to the power of m is equals to a to the power of m over the n. Notice, there you go. That's what it means. Now let's move on. Please take a screenshot. You can take a screenshot, freeze this, put it on your table, put it on your wall so you know and understand how to work this. Memorize it if you need to, but you need to know this. Next, let's move on to the basic difference of two squares. Now here we're going to look at the basic difference of two squares. The difference of two squares basically is you working out back. Remember, factorization is the reverse of multiplication. I want us to start with a very basic one. Let's look at x minus a times x plus a. When you use FOIL to multiply this out, FOIL to multiply this out, this is what you get. X times x, that is the first terms, that's x squared. And then you've got x times a, that is ax. And then you've got negative a times x, that is minus ax. And then the last terms are negative a times a, that gives you negative a squared. Now notice that the middle terms add to 0 because that's a cow minus a cow, that gives us 0. Therefore, you are left with x squared minus a squared. And that's what happens with all difference of two squares. Similarly, so how do you do it? Here is a shortcut. You just go equals to, open two pairs of brackets, one pair, and then another pair of brackets. Okay, in the first term of each bracket, you find the square root of the first term. The difference of two squares basically mean the minus of two squares. So it's one square and another squares, and the difference is the minus showing in the middle. So that's the difference of two squares. That's when you subtract two squares. What is this? The square of 4x squared is the square of the combination of the square of 4, that is 2, the square root of 4, and the square root of x squared is x. So that is the square root of 4x squared. And the square root of 9 is simply 3. So what you do in the first terms of each bracket, you go the square root of the first term, which is 2x in this case. And in the last terms of each bracket, you put the square root of the second square. And that will be 3 in this case. And in one, you simply put plus, and in the other, you simply put minus. Why? Because then when you add the middle terms together, they will give you a 0, which leaves you with simply the square of the first term minus the square of the last term. And that's how you do it. Look, so same story over here. Two pairs of brackets. Now we find the square root of the first term. Square root of the first term, it will be compound here. The square root of 25 is 5, and the square root of a squared is a. The square root of 16 is 4, and the square root of b squared is b. So here, that will be 5a and 5a, and then in the second ones, it will be 4b and 4b. And that's how you work this one. And in one bracket, you put plus, and in the other bracket, you put minus. That's all it takes to factorize the difference of two squares. It's this easy. Let's look at the complicated version. The complicated difference of two squares is what comes like, it's almost like a difference of two squares, but it's not quite. 2 is not a perfect square. 72 is not a perfect square either, for example. But if you were to take out the common factor between 2 and 72, which happens to be 2, you will see then your difference of two squares will start showing. So if we take out 2 as a common factor, so that will leave us with m squared minus 72 divided by 2, that is 36. Now notice that m squared is the square of m and 36 is the square of 6. So we have a difference of two squares. So now what we do is, after taking out a common factor, that common factor must stay there. And now we go on and factorize the difference of two squares. How do we do that? We take the square root of the first term. The square root of m squared is m, so we put that in the first bracket in each bracket. The first term in each bracket, and then the square root of 36 is 6. So that will be, and then we simply put plus in one bracket and minus in the other one, and that's it, you're done. So take out a common factor first. That's when the difference of two squares will be very evident for you. Now what happens when you have a situation like this? You've got p to the power of 4 minus 16. This also is a difference of two squares, but I wanted to notice something. After factorizing this difference of two squares, you will see something, and I want to show you what that something is. So step number 1, we must write two pairs of brackets, and in the first one we write the square root of the first term, and in the second terms of the brackets we write the square root of the second term. So the square root of p squared is p to the power 2 to the power of 4. The square root of p to the power of 4 is p squared, so we put that in each one of the brackets, and the square root of 16 is 4, so we put that in each bracket. One will be plus and the other will be minus. It does not matter where you put the plus or where you put the minus, wherever you want to put it, that's perfectly fine. Now notice that when you look at p squared minus 4, it is further also classified as another difference of two squares. So when they say factorize fully, you need to also continue factorizing this until it is factorized fully. So we have another difference of two squares that we need to factorize. Notice that the sum of two squares cannot be factorized. This is the sum of two squares. You can't do anything with it. You just leave it the way it is. So we are done with that one. So let's continue factorizing this difference of two squares. So the square root of p squared, that is p, and then the square root of 4 is 2, and we'll have plus and 1 and minus and 1. And this is how you fully factorize the difference of two squares that can still afterwards be factorized as another difference of two squares. We've come to the end of this video. Thank you so much for watching. I'll see you in the next one.